Hello, today I want to show you how to compute the sum of the divisors for every positive integer n. If we know that n's representation is p1 to the alpha 1 power, p2 to the alpha 2 power, and pk to the alpha k power, gamma of n is the sum of the divisors, and tau of n is number of divisors. We know that all of its divisor must be of the form p1 to the beta 1 power, p2 to the beta 2 power, up to pk to the beta k power. And what are the restrictions for each of bi? Bi may be 0 if this divisor does not have any divisor which equal any prime factor which is pi. In this case, bi must be 0, and the greatest value of bi must be alpha i. So we have concluded that 0 is less or equal to bi and bi is less or equal to alpha I. So in total we have alpha I plus 1 different possible choices for beta I. And because we know that all of the divisors can be uniquely determined by this prime factorization, and for beta 1 we have alpha 1 plus 1 different choices. For beta 2 we have alpha 2 plus 1 different choices. This is 2. And for beta k we have alpha k plus 1 different choices. Now we will see that total number of divisors must be alpha 1 plus 1 times alpha 2 plus 1 times up to alpha k plus 1 times. So this must be the total number of possible choices. And to find the total number of total sum of the divisors, we need to look at also the unique prime factorization of each prime divisor or each divisor of n. And we will see that 1 plus p1 up to p to the alpha 1 times 1 plus p2 plus to the p2 to the alpha 2 power multiplied by up to so on 1 plus pk up to pk to the alpha k power. This will give us the sum of the divisors. And now check why it is correct. If we are given any number called d divides n, and d equals p1 to the gamma 1, p2 to the gamma 2, up to pk to the gamma k, we will choose the number gamma 1 from here. For gamma 2, we need to choose this number from here. And for gamma k, we need to choose this number for last brackets. So we will see that all of these divisors will be uniquely determined by these brackets if we expand all of them. And we can also be sure that all of the divisors must be in this form. So the total sum of the divisors must be 1 plus p1 up to p1 to the alpha 1 times 1 plus p2 up to p2 to the alpha 2, then up to 1 plus pk up to pk to the alpha k power. And we can simplify this more. If we imagine this as the geometric sequence 1 plus p1 plus p1 to the alpha 1 power, clearly this equals b1 is 1, p1 to the alpha plus 1 minus 1 over p1 minus 1. If we expand this one, we get this. This is clearly for the formula of geometric sequence. Or if we expand this one, we will see that these two things are clearly equal to each other. So the best formula for computing the sum of the divisors of every positive integer n will be like this: p1 to the alpha 1 plus 1 over p1 minus 1 times p2 to the alpha 2 plus 1 minus 1 over p2 minus 1 up to pk to the alpha k plus 1 minus 1 over pk minus 1. This was all I want to discuss for today. If you want to discuss or consider some theorems, please write in the comments, and don't forget to like and subscribe my video.